Hello everybody, welcome to Guidancee Education channel. We will see the topic that is discussed in this video. We are continuing class 11, physics, motion in a straight line. In this video, we will discuss reaction time and stopping distance. I will explain this topic and also derive the formula to calculate these quantities. Please watch the video completely without skipping so that you get all points cleared. And if you think the video is useful, do like the video, share the video with your friends and also leave your feedbacks as comments in the comment box below. If you have not yet subscribed my channel, do subscribe it now and support me. Press the bell button and all button for notification of more videos like this. Thank you very much. Come, let us see the topic. First, we will discuss reaction time and then pass on to stopping distance. You are driving a car and somebody crosses the road all of a sudden. You see him and then immediately apply the brake. But there is a time lapse between you seeing the person crossing the road and applying the brake. This time lapse is called reaction time. Reaction time depends on two factors. One is presence of mind of the driver and two, the complexity of the situation. That is, whether there is any complex traffic on the road. Reaction time is a very important aspect in road safety. Less the reaction time, more the safety. I have given here two persons engaged in a task here that is given to help you understand how the presence of mind of a person can be determined. That is the one factor which decides reaction time. The reaction time can be determined by this experiment. Person A holds a rod vertically in his hand between the forefinger and the thumb, and when he releases it, B has to catch it in no time. B sees A dropping the rod and immediately catches it. But a time lapse happens there. By the time he catches the rod moves a little downward. Let us see that. This is the initial position of the rod. That is before dropping the rod. Now A drops the rod and B catches it. But in the meantime, it moves by a short distance. Let the final position be as is shown here. The time taken by the rod to move this short distance d is the reaction time. So we have to calculate the time taken for moving this small distance d. The downward motion of the rod is due to Earth's gravity. So it is experiencing an acceleration equal to acceleration due to gravity g. Let the distance d through which the rod moves be equal to d is equal to 0.21 meter. Acceleration due to gravity g is equal to 9.8 meter per second square. We are taking the value as positive. We will use the formula S is equal to ut plus half gt square. Here S is equal to d equal to 0.21 meter is equal to u is equal to 0. So ut is equal to 0 plus half 9.8 into t square. 2 in the denominator of the right hand side is shifted to left hand side. So 0.21 into 2 is equal to 9.8 into t square. T square becomes 0.21 into 2 divided by 9.8, and t will be equal to root of 0.21 into 2 divided by 9.8. On simplification, you will get the value of t as equal to 0.2 seconds. So in this case, the reaction time is 0.2 seconds. That is, there was a time lapse of 0.2 seconds between the person B seeing the rod moving down and his catching the rod. I hope it is clear. Now we will pass on to the next topic, stopping distance ds, and derivation of the expression for calculating ds and the significance of stopping distance. A person is driving a car and he immediately sees somebody crossing the road. He immediately applies brake and stops the car. But before the car stops, the car travels for some distance, and that distance is called stopping distance. Before the car stops, it gets decelerated. Its acceleration gets reduced. Then only it stops. So it takes some time. So it moves some distance. Stopping distance depends on two factors. First one is initial velocity, that is a velocity with which the vehicle is moving. Second one is braking capacity, that is deceleration, equal to negative A. What is the significance of stopping distance? Stopping distance is primarily concerned with preventing road accidents. So it is associated with road safety. So it's very important. In order to understand its significance better, we will first derive an expression for calculating stopping distance. We will derive it from the kinematic equation v square is equal to u square plus 2as. Since after applying the brake, the vehicle is getting decelerated, we have already said that its acceleration is deceleration equal to negative A. So the equation becomes v square is equal to u square minus 2as. Initial velocity has some value. It is moving with some velocity. But final velocity v is equal to 0 because it is stopping. So 0 is equal to u square minus 2as. So we shift to u square to the left hand side. So negative u square is equal to negative 2as, which can be taken as u square is equal to 2as. Here the parameter s in this equation is equal to the stopping distance ds. So we get u square by 2a is equal to s, which can be written as s is equal to u square by 2a. Now this equation will tell you the significance of stopping distance. That is s is equal to ds. 2a in the denominator on the right hand side of the equation is a constant. So we may say ds is directly proportional to u square. Is when initial velocity increases, stopping distance also increases. But by how much? In order to understand this better, let us just rearrange this as 2a ds is equal to u square. If we increase u square twice, that is, if it becomes equal to 2 into u square, then the left hand side will become 2 into 2a ds, which will be 4a ds. So if the initial velocity is doubled, that is, if a vehicle is coming with double the speed, the stopping distance will increase 4 times. That is why the stopping distance is very important. In school zones, you would have noticed the board where the speed limit is restricted to a very low value, so that even if a student or somebody crosses the road unexpectedly, the driver can apply the brake and within a short distance, the vehicle will come to a stop. That is, the stopping distance will be much reduced and this will help avoid accidents. Hope you have understood the significance of stopping distance and also the formula to calculate stopping distance. That is, ds is equal to u square by 2a. If you could learn something new from this video, consider subscribing my channel and also leave your feedbacks as comments in the comment box below. Do not forget to like my video and share it with your friends who may also be benefited. And also press the bell button and all button for notification of more videos like this. Thank you very much. We will meet in the next video with another important topic like this. Till then, bye. Take care.